Okay, we got one more type of transformation to talk about, and that is dilations, which basically means taking an original figure and either expanding it, making it larger, or shrinking it and making it smaller in proportional amounts. So what do we mean by a dilation? A dilation is a transformation that produces a figure that is the same shape but different in size, and they are similar, meaning that the figure, whether it be smaller or larger, differs by the same amount. Like maybe it's twice as big or half as big, that kind of thing. So dilations. A dilation is a transformation that either enlarges or reduces the size of an original figure by a given scale factor. To dilate a figure, all you do is multiply its dimensions by the scale factor. Scale factor is a ratio of the corresponding sides in a figure. So if you can find any two corresponding sides, such as the new over the original or the image over the pre-image, and then if you divide that, you get a little number that's called the scale factor. And then that scale factor is multiplied by each of the coordinates. And for example, if you have a triangle, you'd multiply that scale factor by each of the coordinates of the three corners on the triangle, and then replot it, and then you would have your new figure. So if the scale factor is greater than 1, it will enlarge the figure. If the scale factor is less than 1, it will reduce the figure in size. So for example, here's an original, a little black one on the inside, and what it looks like on the outside after we've had a dilation of 2. So let's look at the pre-image, the first one, and write down the coordinates. So S would be negative 2, 0, negative 2, 0. J would be 2 and negative 2, 2 comma negative 2. H is negative 1 and 2. And then if we look at the other ones, the S prime would be negative 2, or excuse me, negative 4, 0. J prime would be 4, negative 4. And H prime would be negative 2 and 4. So the coordinate rule would look like this. The original XY values of the inner or pre-image shape are changed such that you double or multiply each of them by 2 to get the new coordinates. And then when you get your new coordinates, you can draw lines between them to get your new shape. All right, that was pretty straightforward, wasn't it? Okay, how about this one? Let's look at our pre-image. And this is when you have a dilation of 5. So you're multiplying by a number that's smaller than 1. So the object is actually getting smaller. So let's look at our pre-image points. So start with Z. Z is negative 1, 2, 3, 4, and comma 3. Negative 4, comma 3. N is negative 2, comma 1, 2, 3, 4. Negative 2, comma 4. R is negative 1, comma 3. Negative 1, comma 3. And M is negative 2, comma 0. All right, for our new shape, M prime is negative 1, comma 0. That's a 0, by the way. R prime is negative, R prime right here is negative 1/2, comma, 1 1/2. And n prime would be -1, 2. And of course the z prime would be -2, 1.5. I guess down here where I put 1 1/2, I could have put 1.5 as well. So there you go. So what is the coordinate rule then? The original x, y values were transformed such that you multiplied the x values by 1/2 and you multiplied the y values by 1/2. Or you could have written it this way: 0.5x, 0.5x, 0.5y. That's our rule. All right, what if we have one like this? If we have a dilation about the origin of 2, that means we're going to double everything. So all we have to do really is to come along here and just multiply everything in here by 2 and double it. So our new f values will be -2 and 2. Our new e value will be -2, 4. Again, I'm multiplying each of these coordinates by 2. Our new d values will be 2, 2. And our new c values will be 0, -2. We're just taking each coordinate, original coordinate, and multiplying it by 2 to get the new coordinates. All right, so let's do one more with a dilation of 0.5. So in this case, we're going to multiply everything by 0.5 all the way across. Maybe I could just write them all down just to get the point across here. Multiply by 0.5, multiply by 0.5. A little sloppy over there, but okay, what's 0.5 times 2? Or 1/2 of 2 is 1. 1/2 of -2 is -1. 1/2 of 1 is 1/2. 1/2 of 2 is 1. And then 1 or 0.5 times 3 would be, for y prime, 1.5. So half of 3 is 1.5. And half of -2 would be -1. And on this one, on the x value, x prime, I could have written it as 0.5, 1, right? So write a rule to describe the dilation. Choose one new point, A prime, write its coordinates, and then find its matching old point, A, write its coordinates, x, y. So we're kind of doing the new image first, and then the old image second, and then we're finding out we're dividing the new image's, one of its values by one of the old image's values, and that gives us a scale factor. So let's do one of those. So again, we're doing the new image first. So find one point. So let's look and see what's a good point to use. All right, how about let's go with this is kind of challenging actually. But let's go ahead and use W. So we've got -0.5 and 2.5. So W prime is -0.5, 2.5. And then our old image, W itself, is -1 and 1, 2, 3, 4, 5. So -1 and 5. So then let's go back and see what do. We divide the new point by the old point. So if we divide by this, we notice 0.5 divided by 1. Oh, we've got to double check. This is W right here, not W prime. So let's go back. We divide the new point by the old point. So 0.5 divided by negative 0.5 divided by negative 1. So what would that equal? Well, that would just equal 0.5, right? And the same with this one.
Okay for vacuum?
Yeah, come on in. So that would be our scale factors, 0.5.
Okay for vacuum?
Can you give me about one more minute?
Yeah.
Okay.
I'll be right back.
All right, thank you. On this last one right here, actually, that is our assignment. We're doing the dilations worksheet. And so here's some example problems. So on this first one, we're going to do a dilation of 1/2, which means we're going to multiply everything in there by 1/2. So if we look at our first point, 2, 2, which is y, right? That's our y value. And then our z value is 1, negative 3. And our w value is negative 2, negative 1. Then our x value is negative 1 and 1, 2, 3, 4. So our x value is negative 1, 4. All we have to do now is multiply each of those numbers by 0.5. So when we do that, multiply by 0.5, then everything basically gets divided in half. So y prime will be 1, 1. Z prime will be 0.5, negative 1.5. W prime will be negative 1 and negative 0.5. And then our last one, x prime, when you multiply each of those by 1/2, will be negative 0.5 and 2. So then when you plot those, you'll have your new figure. So 1, 1 would be y prime. 0.5 and negative 1.5. So 0.5 and negative 1.5 would be z prime. Negative 1 and negative 0.5, negative 1 and negative 0.5 would be w prime. I'm kind of putting these letters way out there so they're not in the way. And then negative 0.5 and 2. So negative 0.5 and 2 would be x prime. So our new image would look something like that. So that's the idea on the worksheet that we're going to do. So just kind of looking at a couple of problems. We can do those in class together. If you have any more questions, thank you very much.